A tubular shaft having an inner diameter of 30 millimeters and an outer diameter of 42 millimeters is to be used to transmit 90 kilowatts of power. Determine the frequency of rotation of the shaft so the shear stress will not exceed 50 megapascals. Okay, so as we look at this, we've really got one equation, and that's the maximum shear stress is going to be Tc over J. Now, what I'm trying to figure out is the frequency of rotation. So, what we're going to need is we're going to need our power equation. And so power is equal to 2 pi F, which is our frequency, times the torque. Okay, so let's just take a look and see what we have in this equation. I know what my shear stress is because it's not supposed to exceed 50 megapascals. I know what C and J are because they're given in the problems. I know what P is. I know what I'm going to be able to find torque from this other equation to finally get to my F here. So, first thing let's do, let's figure out torque. So, T max is Tc over J. And I'm just going to rearrange that and say that my torque is going to be my T max times J over C. So our maximum shear stress available is 50 megapascals, 50 e to the 6 Newton per meter squared, times it by J. So J is going to be, let's come up here, so of a circular is going to be pi over 2, radius to the 4th. Now I have a tube. So I have an outside diameter and an inside diameter. So remember, for us to get this donut, what do? We do a superposition. We take the J of the big guy, subtract from it the J from the inside. So that's going to be pi over 2 because that's common for both of them. So the outside radius is 0.21. Because remember, this is diameter. So 0.021 meters. I'm converting it to meters to have all the units work out to be correct. Raised to the 4th. And actually, let's bracket this a little bit differently, because we're going to need pi over 2 on everything. And so we want to make sure that we raise the 0.021 to the 4th, and then subtract from that the inside radius, which is 0.015 meters to the 4th. Once again, it's very important to do each of these individually. 0.021 to the 4th minus 0.015 to the 4th, because that is not the same as doing the outside radius minus the inside radius and raising it to the 4th. So you do have to do those separately. And then we're going to divide that by C. C is the distance from the neutral axis to the outside surface. So in this case, we want the outside one, 0.021 meters. So we've run out of room. So we put all that together and calculate it. We're going to get a torque of 538 Newton meters. So at this point, we go to our power equation. Power is equal to 2 pi frequency times the torque. And so all I'm going to do is just rewrite this equation for frequency. So that's going to be power divided by 2 pi torque will give me frequency. And so at this point, we just plug everything in. So we have a power of 90 kilowatts. So 90 times 10 to the 3rd is our watts. Newton meter per second is what our units for watts are. Divide that by 2 pi times our torque, which is 538 Newton meters. So now if I look at the units here, that's going to cancel out, that's going to cancel out. I'm going to be left with inverse seconds. And so that's a cycle or a hertz. And so if I bash this into my calculator, what I get, 26.6 inverse seconds, which is 26.6 hertz. And there we go. That's all there is to it.